everybody, welcome. We are in week 16, and in this video we are going to be reviewing factoring because we are going to be doing a ton of factoring in this chapter. So you have this handout and there are quite a few problems, and I'm going to walk through a good amount of the problems with you, but then I'm going to let you wrap up the problems, and this is something you're going to be turning in. So let's start with factoring. All right, so remember that the first step in factoring is to always look for that GCF, the greatest common factor. So in these two problems, we're only going to factor out the GCF, and then that's it. So I'll do one of the problems with you, and then I want you to try the other one on your own. So the problem I want to do with you is actually number 2. So one of the first things about factoring is that your problems do need to be in standard form, which I think you'll find that these all are. But the other thing is, when we do factor, we really like our leading term, the one right in front, to be positive. So when you see a negative number here, you are guaranteed to factor out at least a negative. And so now when I look at what can I factor out of all of these, I can factor out a -5 from each term, but I won't be able to take a v from each term because they don't all have v's. So I'm going to factor out -5, and when we factor, we are just finding the neighbors. Who did -5 meet to get this? So we will be going from standard form to factored form, but remember, factored form is when the neighbors meet the neighbors to get you standard form. So -5 times a v squared would make -5v squared, and then -5 times a -1 would make the -5v, and I'll put a v there. And then -5 times a positive 1 would make that -5. And remember, factoring is when you can multiply two things to get what you start with, but it's also just using division. So I just divided all of these terms by -5. So your job now is to do number 1. Remember, you're only going to do the GCF. So in the next section, there's quite a few. There's 6 of them here, so I'll do a few of them with you, and then I'm going to let you do the rest on your own. Is that when there are 3 terms, you should try to factor using your x. Don't forget to always check for a GCF first. So let's find a problem that does have a GCF. And again, just looking real quick, these are all in standard form. So just a reminder, that's where you have your highest exponent, then the next, and then you just keep working down until you hit a constant. So in this problem, what I notice is I can factor 2 out of everything. And then I can also factor an x out of each term. And so again, we're just finding the neighbors. So 2x times what makes 2x cubed? Well, I already have the 2, so I'll have x squared. And then 2x times what makes -22x squared? Well, that would be a -11 for the -22, and then I need another x. And then 2 times what makes the 60? Well, that's 30, and I already have the x to get to the 60x. So from there, what I'm going to do is look at these 3 terms, and I'm going to keep factoring. And when you have 3 terms, you want to make your x. And if you remember, you multiply those for the top part, and the middle goes in the bottom. And then you would run your factor program, or you could use a factor page and find the factors of 30 that get you to -11. And so the side numbers are going to be, I'm writing the second one wrong, 6 and 5, and I'm going to have to make them both negative. So when I multiply these, I get the +30x squared, and when I add them, I get the -11. So first, what I'm going to do is just drop down my GCF. That is one of my factors, and now I'll make my factors, or my neighbors, for the x squared minus 11x plus 30. All right, these are the important numbers. These are done. Their only job is to help us get the side numbers. So if you remember, when this neighbor meets this neighbor, so when the first term in these parentheses meets the first term in these parentheses, you get the first term here. And to get x squared, you need an x and an x. And then from there, we can make what I call the face. So you're going to loop the outside to the outside and the inside to the inside. If you look, this is like the top of the head, and this is the smile, and the parentheses are the eyes, and it's a very squished face. So x times x makes x squared. So now these x's are going to make these side numbers. So since they're both x, it doesn't matter which one I start with. So x times what makes the -6x? Well, that would be -6. And x times what makes negative 5x? Well, that would be a negative 5. And now you have factored it. In previous chapters, we've gone on one step further and we've solved what makes each factor equal to 0. But in this chapter, we're not solving. We're just factoring. So in this problem, we have three factors. The GCF is 1. X minus 5 is our second one. And x minus 6 is our third factor. So it would take all of these neighbors to meet to get to this. And again, so if these neighbors meet, I get this. And then when 2x meets this group, we get right back to where we started. So let's try another problem. Let's try one that doesn't have a GCF. So the problem I want to do with you now is 7. So there isn't a GCF, and with 3 terms, I'm going to go straight to my x. And I have factors of negative 20 with the x squared. That makes a 1x. And so those numbers are going to be 5 and 4, and we're going to have the 4 be negative. Okay, so I'm ready to make my parentheses. I'm ready to make the neighbors who are going to meet to get this. So again, when this first term meets this first term, it should make 10x squared. So far, the easy part is x times x will make the x squared. But now what I need is to figure out, I'm looking for a pencil here. I need to figure out the numbers that are going to make 10 from the 10x squared. So I actually have 2 choices. I could use 1 and 10 to get 10, or I could use 2 and 5. So the way to figure out which ones to use is I'm going to go ahead and draw these loops. Because when I draw these loops, I'm working to get these numbers. The top and the bottom have done their job, all right? It's the side numbers that I want. And when I look between 1 and 10, which numbers can make what? So 1 can make either of these. 1 times negative 4 would make that, and 1 times 5 would make that. So 1's not very picky. So what I really want to look at is 10. Can I take 10 and multiply it by an integer, so not a decimal or a fraction, to get those? And you can't. So that is why 1 and 10 are going to be eliminated. So then I'm going to look at 2 and 5. And 2 can make the negative 4x, and 5 can make 5x. So I'm going to choose 2 and 5. And so since I already said 2 can multiply to something to make the negative 4x, now we already have our x for the x here. So I just have to ask myself 2 times what makes the negative 4, and that's negative 2. And there's your negative 4x when you multiply them, if you want a little reminder. And that means 5, we already have the x for here. 5 times what's going to make the 5, and that would be a positive 1, and I get that 5x. So here are my factors. In this chapter, we're done with our factors. We're not going to solve. So what I want you to do is take a look at the other sets. And so number 8, just a reminder to look for a GCF. Between 36 and 24 and 32, the number that you will be pulling out from all of those will be a 4, and then you'll be able to take at least an x from each term. So that gets you started on number 8. Let's go ahead and take a look at the back. So now, when there are 2 terms, you should try to factor using difference of squares. But again, don't forget to always check for a GCF first. And I'm going to explain once again why this is called a difference of squares. So 2 problems to look at. Let's just look at this one. This one is a difference of squares. The reason why it gets its difference of squares name is because difference means I should see subtraction between the terms, which I'm due. I see subtraction. But the squares mean that each term has a nice square root. So x squared, so there's the subtraction. That's the first start for a difference of squares. And then these both have nice square roots. The square root of x squared is x, and the square root of 25 is 5. And from there, you can make your neighbors, or your factor parentheses, and put x plus 5 in one, and x minus 5 in the other. And difference of squares is going to be really big in this chapter, so it's one we got to remember. So from there, let's pick one that does have a GCF. So on 12, what I notice is I can take an x from each term, and then x times 16x squared makes that, and then I need something here. I can't just put nothing. X with the negative 1 makes that negative x. So here what I'm looking at is just what's in the parentheses, and is this a difference of squares? So there's the difference, and does this have a square root, and does this have a square root? And it does. So joining the x, that GCF, will be 2 new factors, and I'll take the square root of 16x squared, which is 4x, and I'll take the square root of 1, which is 1. I'll put them in both of them and then have a plus and a minus. And now this one is factored completely. It has all its factors. X, our GCF, 4x plus 1 is our second factor, and 4x minus 1 is our third factor. So I think for this one, I'm going to do one more with you, and it's going to be 13. And let's talk about what if there's an exponent that's not a 2, because that's going to happen in this chapter. So this is still a difference of squares because there's a difference. And then these actually do have square roots. So when you take the square root of 16, you get 4. And when you take the square root of x to the 4th, you're actually just cutting that exponent in half. So it becomes x squared. And then the square root of 1 is 1. So from here, I can put 4x squared plus 1 and 4x squared minus 1. And then one thing that's going to happen quite a bit in this chapter is you're going to think you're done factoring, but actually you're not, because this is another difference of squares. So while this one's not because it has a plus, and it would just drop through, carry down, whatever you want to say, 4x squared has a square root, and 1 has a square root, and there's a difference. So from here, I can get 2 more parentheses, and it will be 2x for this one's square root, and 1 for this one's square root, so 2x plus 1, and 2x minus 1. So you always want to make sure that you're done. And so the one to double check for is there a difference of squares, or did I forget about it? So in our last section, when there are 4 terms, you're going to try to factor by this grouping method. So 2 in parentheses, 2 in parentheses. But again, don't forget to always check for a GCF first. So let's start with a problem that does have a GCF. Let's start with 16. So when I look, first I see an x out of everything, so I'm going to take an x out. And then when I look at 6 and 3 and 2 and 1, there's not a number that goes into all of this. So I'm only going to be taking an x out. So x and what makes 6x to the 4th? Well, that's 6x3. X and what make negative 3x cubed? Well, that'll be a negative 3x squared. Basically, it's just what it was, but all of the x's just drop down by 1. So this is a GCF. So now what I'm going to focus on is just what's in here, these 4 terms. And so to not confuse things, I'm just going to rewrite it here. And as I rewrite it, I'm going to put the first 2 in parentheses and the last 2 in parentheses. And this is where it's just a bunch of GCFing. So first I look for a number, and I can factor a 3 out of both of those. And I can also factor an x squared. So 3x squared and what makes 6x cubed? Well, that would be a 2 and an x. And then 3x squared and what makes negative 3x squared? Well, that would be a minus 1. And so now when I factor this one, and I just realized I made a mistake here. This shouldn't be an x because I factored that x out. That should be a 1. So let's fix it there. So when I go to GCF this one, these will have to match. So when I'm done, what should still be left in my parentheses will have to be 2x minus 1. And so that means I'm factoring out a very particular number. So what with 2x makes negative 2x, or what with negative 1 makes a positive 1, and that would be a negative 1. And then I had you draw these brackets because joining our GCF of x, right, that's this one right here, is going to be 2 new sets of parentheses. And your brackets tell you what's going in each one. So this bracket is telling you in one of them, put 2x minus 1. And then this bracket tells you to put 3x squared minus 1. And then you should always double check, am I done factoring? So is this a difference of squares? No, because 2x doesn't have a square root. And is this a difference of squares? No, because 3 doesn't have a square root. So this is it. You have factored this one completely. All right, let's talk about the typo that's here. So this should not be an R. Take that out. And then on this one, there is a GCF. Even though you can't factor an x out, you can actually take a 3 out from every term, and I do expect you to take those out as well. GCF is very important in this chapter. So that's it. You're going to work on this a little bit on Monday, and then we'll finish it up in class on Tuesday.